So here's a second example of how to find the formula for parabola, but this time we're giving a directrix of y equals -7. So remember on the last example, we had the directrix x equals something. This time we have y equals something. So what is that going to tell us? Remember I told you the trick. If your directrix is y equals something, that means you start with the formula with x, opposite day, right? Because your parabolas are going to go either up or down. Well, let's just kind of take a look at that practically, what that looks like. If y equals -7, if I just go down 7 from the origin here on my y-axis, 1, 2, 3, 4, 5, 6, 7, that means my directrix is going to be somewhere right around in here. That's going to be the line that constrains my, well, not really constrains, but it's going to be the line that is equidistant to the focal point from the vertex of my parabola. And the vertex of my parabola is -2, -1. So let's just take a look at that. So if I went from here and I went -2 down 1. So that is the vertex of my parabola, which means my parabola has to turn up like this. It can't turn down because it cannot intersect the directrix. So that means this is my vertical, my vertices, this is my directrix, and my focal point is going to be somewhere up here because it's going to be equidistant. So if this were the distance between my vertex and my directrix, it's going to be the same distance between my vertices and my focal point. I'm just guessing somewhere around in there because there's the same. Do you see that? Okay, but let's forget about that for a minute. So let's look at the formula that I got to use to find the formula for this parabola. So if my directrix is y equals 7, that means I'm going to use the opposite one. I'm going to start with my x this time. So we have x minus h squared equals 4 times p times y minus k. And there's no squared over here, just squared on this first term. Well, so this is my h and this is my k, but what is p? Remember, p is the distance between your vertex and your directrix, or your vertex and your focal length. It doesn't matter. It's the same. Okay, that's what p is. So all I have to do is I look here and I say, well, I have the y equals -7, so that means I'm going to look at this y value. Remember, x and y. If this y equals something, then I'm going to look at my y value and say this minus this. So my p equals -1 minus this guy, -7. So really that's saying -1 plus 7. So what is -1 plus 7? Well, it's really saying 7 minus 1, which is 6. So now I know that p equals 6. So you just look. If this directrix is y, then I'm going to say this y value minus this. As opposed to the last example where this directrix was x, so we said this x value minus this. Okay, so you've got to pay attention. It's a little confusing which one to subtract, but always just think in terms of x, y. This one's y, so I'm going to use that one. That minus that. Okay, so now I'm just going to substitute in my h's and my k's, and it's going to be super simple from here. So I have x minus h, which is -2. Oh, so that makes that plus 2 squared, right? Because negative times negative is positive, equals 4 times p. Well, what's p? P is 6. So 4 times 6 times y minus k. Oh, k is a -1, so that turns that to a +1. And then all I have to do is just multiply this, and then I'm done. So x plus 2 squared equals 24 times y minus, or plus 1. Boom. Done.